Okay, today we're going to talk about tangents. I introduced tangents to you when we first started this chapter when I showed you all of the different line segments that play a part in circles. Radii, diameter, chords, secants, tangent. Okay, we have seen how secants create angles. Same thing you're going to find with tangents. But tangents, remember, never go inside a circle. They always stay outside. Okay? Think tire for the circle, road for the tangent. Touches at one spot. We call that the point of tangency. Important. Okay, resources, chapter 9 notes, pages 3 and 4. I put a lot of the examples up there. Okay, and your PowerPoint. Okay, chapter 9, section 5. Now, a tangent is simply, as I said, a line that touches a circle. It can be a line, a segment, a ray, but it just touches once at the point of tangency. You're going to see the term common tangents. That's simply a tangent that is tangent to more than one circle. Okay? When we have two circles that are apart like this, we have 4 common tangents. Outside, outside, and those that pass between. Okay? Same here. Now, here you'll notice the circles are tangent to each other. Okay? Think about a snowman or the number 8. They touch each other. Okay? You can still have common tangents that touch both of the circles. Now here, this is another way that circles can be tangent to each other. Okay? One is inside of the other. It's kind of funky. It looks like if you're looking at an olive or an eyeball type of thing from the side. I know, I'm silly. Okay. When a tangent is perpendicular to a radius at the point of tangency, okay, the Pythagorean theorem will come into play. Now, not only can we use the Pythagorean theorem to find a missing side of this particular triangle, but remember the converse of the Pythagorean theorem, where it says, if a squared plus b squared equals c squared, then it's a right triangle. We can use that to determine whether this is tangent to the radius. Okay, because if it does form the right triangle, then it's perpendicular. That's how we're going to check it. We'll have an example of that later. Also, if you have two tangents drawn from the same point, okay, from the same point to the same circle, they're equal in length. So from our example over here, these two lengths are the same, these two lengths are the same. Okay? These two are the same. It doesn't matter if it creates polygons circumscribed around the circle. The tangents are going to have the same distance from point to circle. Let's go to the examples. Okay. Our first two here, as I said, oh, and there's that lovely light bar again, is MP tangent to the circle. Okay. Well, we have 3 numbers there, and we're going to use the Pythagorean theorem, and it's just going to be as simple as this. That's our question. Okay? So we're going to use our math. Okay? Since that doesn't equal that, they are not a right triangle, not tangent to the circle. Means it's just off a little bit. Okay? That's all we're thinking about. We do the same thing here. Is MP tangent? We're going to do the same thing. Okay? Okay? 14 squared, 48 squared, 50 squared. Combine? Yep, they do. So we check. We got a yes. That is a tangent. Okay, that's what we're looking at there. Okay? Now, next two questions. The directions you see here, you're going to see in the book and in the worksheets. Okay? Find the value of x. Assume that segments that appear to be tangent are indeed tangent. Okay, so we don't have to prove everything. Okay, if it looks tangent, they are tangent. Okay, so to find x, I have two tangents drawn from the same point to the same circle. Those have to be equal to each other. And that's all you have to do for it. Set them equal, solve for x. Okay? On our next one. Now, on this one, it looks tangent, so yes, it's going to be a tangent, which means this is a right angle. So now we can use the Pythagorean theorem. Okay, and that's how we're going to set it up, just like that. We've done that 100 times. Okay. Excuse me. Okay, so in this particular one, we work it down. We've got that. We can simplify it, or if it wants it in decimal form, it's approximately there. We can do all of those, okay? Unlike me, make sure you do the right math, okay? Now, here's more of the common tangents. Okay, we've got two of them over here. Okay, find x and then find the perimeter. Okay, so to do that, let's do a little work. The first thing we have to do is find what's equal to what. Well, we know that if we have tangents drawn from the same point to the same circle, they're equal. So that tells me that this equals this. So, there it is. 3x equals 18. Okay. So, x equals 6. Okay. So, we also know that this length is 18 right here. Okay. If this whole thing is 52, okay, then we know that subtract 18 gives me 34 right here. If that's 34, that's 34. If this is 12, this is 12. Okay, so let's look at the big picture. 18 and 12 is 30 for that side, so the perimeter equals 30 plus 12 and 34 is 46. And we already have 52 over here. Okay, add those up. And that's all you're dealing with. Okay, a lot of addition. That's really all we're looking at. Okay. Next one, it looks a little funky, but here we go. Once again, find x. Well, this is 18, this is 18, this is 6, this is 6, which means 13 minus 6 is 7. If this is 7, this is 7, 14 minus 7 is 7. Kind of an easy one there. Okay? We have 14, we have 13, this is 24. We know that's 7, so that means this is 25. So our perimeter okay? That's what we're dealing with on this particular section, okay? Kind of straightforward. I hope it's going to be easy for you. It's just basic nuts and bolts math, okay? Excellent. I will chat with you later.